Yo, what's up? This is just a quick walkthrough of all of our code that we wrote for Lab 2 of Mechatronics. So first of all, we have our timing.c file. Here we define a couple functions that are all going to have to do with the timer functionality, that we're just then going to use later on for all of our tasks and message handling. Actually, I need task management up here too, I believe. And get to that in a second. But first of all, here we have our initialized timing. Here we're basically just setting all of the right pins that we need to set, right? Setting them to inputs. We're defining our prescaler at one point, just setting up all of our variables, setting it up so the code will actually run. What else? Yeah, we need to clear all our registers for the timer 0 that we're implementing in this. Set the timer, set it to the right mode. I believe we're using mode CTC for this. Then we have timing that time second. So as I should have mentioned, we have a count ms variable inside of timing that just kind of keeps track of how many milliseconds have passed, or like counts the milliseconds. So timing.set actually just takes that and returns it as a float. Then timing.time takes advantage of our time t struct. That I don't believe we wrote that. That was defined for us already in timing.h. But basically, for the milliseconds, we just use our count ms to keep track of those. And for the microseconds, that's actually relying on the TCNT0, which is coming over from our register pin stuff that we set up earlier. But that just timing.time just returns a time t struct of how much time has passed how much time has passed. I guess the different functions have different times, right? How much time that instance has. Then det_milli is just going to return count ms, just going to return the milliseconds counterpart, and then det_micro returns the microseconds counterpart, just in case you want to split up that like time t struct into two different parts. Then second sense just takes advantage of, it takes in a pointer to a time t struct and then uses all that information to gather the time since that has passed. So it gets the current time, and then it takes the time that you pass in and it subtracts them to find out the difference in time, how much time has passed since whatever time you plugged in. And then we have our ISR over here, our interrupt stuff. That's just going to reset the timer to 0 and increase our count ms. So every time the service is interrupted, we increase that counter by 1. Then I think in task management, we just went to all the tasks and we implemented this timer functionality to them. So I think this was already defined, right? Like every task has its run period, the time since it last ran, stuff like that. But now we're defining the run period. We're setting the time since last ran to just the current time when the task is being activated. Because if you think about it, you just activated the task, so that is the time when it was last functioned. I think we just kind of set that logic at different points. Reactivate if the task is ready. We have to make sure that enough run period has passed so that we can actually run the time. So here's like, can we run it? Well, it has the last time is greater than the run period. Stuff like that. Task run, yeah, same logic. Don't run anything if its run period hasn't passed. Also, if something has a run period and -1, we use that to signify, hey, you only need to run that task one time. Then message handling, we had to add technically 4 new messages. I mean, there was only 2 chars associated with them, but we have lowercase t and uppercase t. Both of them, we're gonna receive that char command. We kind of typically just toss that away, right? And then the next bit after that is going to be either a 0 or 1, and that's going to determine whether or not we send we run our send time task or our time loop task. And in the t case, we're only running those -1. We're running them one time. But then in this uppercase t scenario, we're actually running those for some run period interval, whatever the user enters. So we actually need to package that data and then pass it into the task. We call task activate, but we change the run period. We also implemented this command process flag that just runs after command is processed. So then that's going to just determine whether or not we reactivate our watchdog timer task that we set up. Then in lab 2 task, with this whole file, we have to code it from scratch with all the function signatures were existing. But here's where we declare the send loop time and send time now, like what those tasks actually do. So they're going to create some data structure, and then you're gonna pass in your command byte, right? So whether it was a 0 or a 1, whether or not you're sending loop time or time since ran. And then in the case of send time now, you actually just for the current time that's going to be passed out, you just get the current time because that should represent the time that the robot has been running. Then for this send loop time, we did something interesting where we made a null task, basically a task whose only job was to just time how long it took for the main loop over here in timers, just how long it took for that task to run. And then we would just pass in the second since that task was last ran. So we have this task main time that's just tracking the main loop, and then we return the time since that last ran, since that will represent the time that the loop takes to run. And we also had to modify our lab to timers, kind of like the main for this lab. We just had to make sure we were instantiating all our tasks, our send time now with the send time now function call, send loop time with the send loop function call. Like I said, we chose to make a task main time that we pass in a null function to. But as you can see here, that just runs at the start, and that essentially always represents the time since it last ran. We set up all of our different task functions, including the time loop and the send time. And obviously, when we receive a specific message, those tasks are going to get activated inside of these calls. So I think that was everything. Now I'm going to probably cut to some footage of us of our code actually working and functioning. So here is a command from our previous lab, just trying to add some stuff up. And then here is the commands we coded in for this lab. I'll start with this should just return the total time that the car has been running. As you see, it returns 51 seconds, pretty reasonable time. Then if I enter a T1 command, that's actually going to return the loop time, the time that it's taken to do one full loop of like our main. So that's very small, that seems reasonable. But then if we do a capital T and then a 0 and then we enter some sort of flow, like let's say 1, and once we send that, that's in a loop. And as you can see, the command that returns the total time that the robot's been on is just looping every second. And we can do something similar with the runtime. Let's offset that to 2 seconds. Then now we have both commands. There's the 1 second of runtime, and then here's the loop times being sent every 2 seconds. And then finally, if I go ahead and put tilde, that actually resets the system shutdown all the commands.